Okay, this is the second video in the series of videos looking at start of injection. I've just finished looking at what possibly are main injection maps and pilot injection maps, or main injection and pilot injection maps muddled together. And if you've watched that video, you will know how muddling the whole thing is, how complicated it is. Here we've got some correction maps. They're virtually always a mixture of temperature and pressure, and sometimes other factors that the manufacturer has decided ought to be included, and it's difficult to know for sure what's been included, again, especially without a DAMOS. But usually you will find that there might be a group for, say, water temperature correction, and there might be some for air pressure correction, that sort of thing. But you have to look pretty close at them to try and work out what they may or may not be. You can usually identify them as correction maps, because if I get one of these to open, if we look at it, the figures are generally relatively small, and you can see I haven't changed anything here. So that would be engine speed there, and that would be injection quantity, and by the time I'd added a factor to these would all be very small numbers. So the fact that they're very little numbers suggests that they are all corrections of some sort. Now I'll just skip past those, because what I want to get onto, these again are more corrections here. What we've got coming up here are some maps that have got these very high values up here. Now these very high values represent large numbers, and large numbers, generally speaking, represent negative numbers once you get to a reasonably high number. So if we look at this one, let's pick this first one. The axes are the same because it's still start of injection. The factors are the same, so this is still start of injection crankshaft angle with the same factor. But if we look, what we've got here is something that could start at 0 degrees, or you can see -3, -2, -11 or 12, -16, 17. So you can see what's happening. It has the ability to start reasonably late, because -20 is 20 degrees after top dead center. Now the very fact that these have got all these minus numbers on them, which are a reflection of those big numbers up there, suggests that these are post injections. You'll see what I mean about the minus numbers. It's the sign here that's causing that. If I click off sign, you can see they suddenly become great big numbers, and if I put sign back, they become more sensible, understandable numbers in terms of degrees. And there's the factor that I've used. I tend to use 2 decimal places, because if you use more, the whole thing just becomes complicated to look at, and if you use less, you run the risk of not being able to understand if there's much difference between some of the numbers, because you can see that when you look at some of them, they might come out pretty close, 19.58, 19.51, so that extra decimal point helps a bit. So I suspect that these are post-injection. 1, 2, 3, of 1 there, 4. Now the post-injection maps like this are not related to all the previous start of injection maps, so they don't follow that temperature dependent start of injection selector map that we found at the beginning. So these are not dependent on that at all. They are very often dependent on other factors that are in amongst here. And so again, you would need a DAMOS to dig around in there and see if there are any specific factors that have been put in for these. These are very often referred to as post-injection 2, even though they would be the first post-injection after the main injection event. They're often referred to post-injection as post-injection 2, and these maps are usually so close to pilot injection and main injection that whole bunch of pilot injection 1, pilot injection 2, pilot injection 3, main injection, and this post injection are all part of the combustion process. So all of these together produce the engine power. If we go any further on, we will see more maps that are almost certainly related to the same thing. So if we look at these, they may well be a similar sort of thing. 0 out to minus 20 degrees or so. And we might well find a similar set of maps here. And again, we could expect these are probably correction maps that relate to that. Now, this is something that I may or may not come back to later, because it's yet another complication along with all of these. And if I keep going through, right, here we are, we've found some more. What's this one here? What was that one there? Let's have a look what sort of thing we've got here. Yes, you can see similar sort of thing again, running right out to about minus 20. So they are probably to do with post injection 2 again, or the first post injection 2 that comes after main injection. And again, there's an odd little thing there. Some more of these odd little maps here. Various little maps there. I'm not going to make too much fuss about those at the moment, because what I'm looking for, again, more correction maps, is something that might be significantly different. Now, see, these look like they might be correction maps for the previous post injection. So you can see there's quite a lot of different maps until we reach these. Now, one clue to these here is if I go back, let's see if I can see something. Very often you start to see these sort of maps here like this, and these are usually related to catalyst temperature, which is a hint that what is coming up in the not too distant future is something like this. These are almost certainly post-injection maps, but true post-injection maps, and they're often referred to as post-injection 1, and they often have the same value no matter what file you look in. So in other words, you look at the file, they're all in the region of minus 40 degrees. You can see, I mean, that's minus 37, minus 35, minus 33, minus 32, and then travelling out to minus 43, minus 43. They're very often all in the region of minus 40 degrees. So in other words, they are occurring 40 degrees after top dead centre. By then, the piston is on its way down the cylinder bore. So this injection possibly could ignite, but probably won't. And so the fuel from this injection will carry on down in the cycle and then be still in the cylinder when it goes through the exhaust stroke and is pushed out of the exhaust valve. So this fuel will never be used, and the reason for that is that when it gets to the catalyst, with a little bit of luck, the heat in the catalyst will be enough to ignite this fuel and further heat up the catalyst. So in other words, this fuel is just there to burn anything that might be burnable in the catalyst. So this is what we would consider to be regeneration. So these are true regeneration maps. So we're looking at start of injection maps for regeneration. And we've got 1, 2, 3, 4. And again, they're not really related to that very first little map we saw that was a selection map for start of injection. These are not affected by that original map. These have their own little selection functions, and not the least of which is going to be the temperature of the exhaust gases. So you will know that the catalyst and the catalyst area is usually surrounded by various temperature and pressure sensors, and so these will be getting information from those to decide when and how much fuel should be injected for these post-injection. And these, like I said, are often referred to as post-injection 1, as being the main post-injection. As before, you very often get lots of corrections to go with these. So we've got various other maps that might or might not tie in with that. Very difficult when you look at these to work out, as you can see, are any of these other maps that are nearby actually taking part in what's going on. So it's very difficult to know, looking at the rest of these, just how important they are. Usually you just have to assume that if they're empty, they're not taking part at all because there's no values, and if they're not empty, then they are taking part. So these are probably corrections that are actually being used. They're probably temperature based in some way, possibly pressure based as well, and maybe based on other things that the manufacturers have put in. So there might be various factors there to ensure that the amount or the timing of the start of injection is altered a little bit, just to try to keep the catalyst within that main burn point to burn off as much of the soot as possible. Because of course you can't burn off ash in a particulate filter, but what you can do is you can burn off accumulated soot that's been trapped. Now this can be a little bit confusing, because in fact these maps back here that we think might well be the previous pilot injection, the one that occurs straight after main injection, these do help burn off soot. One of the reasons these were introduced was to help burn off soot. So although these help burn off soot, they are not helping the main regeneration process, the big burn off of extra soot that these haven't actually managed to deal with. So you can see that the whole process is very, very complicated when it comes to start of injection. So you need to be very, very careful if you ever consider altering start of injection maps, because you need to know for sure that you're altering the ones that you want to alter, and you need to be sure that when you alter them you're not doing anything silly with the values, because you do run the risk of damaging the engine if you alter these in the wrong way. Right, I'll stop there.